Good morning. The last time, in the previous video, we tried to apply the similarity theorems to show that two triangles are similar based on the given. Now, let's try to prove two triangles similar, okay, with the given proportionality. Okay, let's try to draw the triangle so you can see it more clearly. This is triangle ABE, and then we are supposed to show. So I'm going to have an exclamation point there that this triangle is similar to triangle DBC. We can only try to show that they are similar if we analyze the given. If we analyze the given here, AB times BC equals EB times BD, I can write those as ratio. So I can say AB here, I can transfer BD to the denominator by MPE. AB is to BD as EB here, EB here, and I transfer BC to the denominator here by MPE. So we got two proportional sides. This is equal to a constant K. And note that this angle here is congruent to that angle there. So we have S and S here, and then A, and then A here, and then another S, proportional. So we are trying to say that triangle ABE is similar to triangle DBC by the SAS, similarity theorem. Okay? Okay, let's take a look at the next number. If you try to see the given again, uh, this is the only thing that's given. MO here is parallel to PN. Okay, we have learned that if two lines are parallel and we have a transversal, we have here this alternate interior angle here, and this one should be congruent. Okay, that's with respect to this transversal. And this another transversal here, okay, which will be congruent. This angle here will be congruent with this. So notice that we already have two congruent angles. Okay, two pairs of congruent angles. So we are hoping to use AA corollary to state that these two triangles are congruent. If you want to get the third angle, this angle here is congruent to that. We don't actually need to do that anymore. So we can just say letter A, MOQ is similar to triangle NPQ. Let's see the correspondence. This is M corresponds to the blue here, and then O corresponds to this P here, red, and then the Q doesn't have any choice anymore. Okay? So which means the triangle MOQ is similar to triangle NPQ. We have proved letter A. Now, for letter A, if MOQ is similar to NPQ, what can we have? As a consequence, we have the sides are proportional. So let's say MO here, MO is to NP, okay, equals MQ is to NQ, and we have here OQ is to PQ. Okay, these are the proportional sides equals a constant K. Now let's see how can we show letter B? MQ times QP. M, is that M? No, that's MO times QP. MO. Okay, MO times QP will be this pair here. This one and this one. I can now have what? MO times what? QP or PQ equals OQ times NP. Okay, that's as a result of this letter A giving you the two triangles that are similar. So you're going to have here, this should be MO and QP and then OQ and P. So we have done letter B. Now what about the next one? What about the third one? MO and NP. No. Or MQ and NP. Okay, MQ and NP, this one here multiplied, and then MO and NQ. So here, the third letter would prove letter C. Okay, so MO times NQ. So MO times NQ equals MQ times NP. So we also prove letter C. Okay? Uh, so we only used AA corollary, and as a consequence to that, we can already have letter B and letter C. Okay, so let's have the next number. What about this one? We are again given proportional sides. Where are the proportional sides here? Uh, PW is to XP equals ZP is to PY. So let's have that drawn. This triangle here, PW. PW here is proportional to, this one is proportional to XP there. And then equals ZP is, remember it's coming from this big triangle. The next proportional sides are these ones here, ZP. They are not congruent. They are proportional. So I'm not writing the tick mark there. Okay, now we just need to, we don't know the relation between the last sides, pair of last sides, but I know that this angle here and this angle here are congruent because they're vertical angles. So I can now say that XPY is similar to what? WPZ by SAS, similarity theorem. Okay? You can just have to write the steps. We will do that in class, the two column proof. So SAS similarity theorem. Now, we have done that one using this given here. Okay, now, we are now supposed to show that XY is parallel to ZW. Okay? XY is parallel to CW. But since X and W are corresponding angles, they must be congruent. Okay? They must be congruent here. And if they are congruent, they are alternate interior angles. Hence, XY should be parallel to what? Parallel to ZW by AIP. Alternate interior angles are congruent, then they are parallel. Okay, let's more formally write this into column proof when we have the class. So somehow you know how to approach proving that two triangles are similar based on the given. Now you can continue doing the rest there. Okay, so this ends the video for the illustration on how to prove that two triangles are similar.